All right, in this video, I'm going to demonstrate using uh, interrupts with the Fubraino Mini. And the Fubarino Mini has interrupts on pins 0, 3, 4, 6, and 24. And you use the attach interrupt. And here's another picture of that same breadboard that I don't know if it's easier to read, but it's certainly less wiry than my actual breadboard circuit. And so the code here to use the attach interrupt has uh, pins 0, 3, 4, 6, and 24 configured as inputs because we're going to use them as inputs, interrupt inputs. And then the built-in LED is set as an output, and it initially is set to low. And we open the serial port at 115.200, and we sit in a while loop until the serial port opens. So the program won't actually do anything until we open the serial port. We put a little bit of delay in here to just give the window a chance to open so we don't miss any data. And then here's the meat of this program, is the attach interrupts. So we do the attach interrupt call, and this function digital pin to interrupt converts our pin number to the interrupt number that is used internally on the microcontroller. And like I said, the Fubarino Mini 2.0 works only with 0, 3, 4, 6, and 24. The second parameter is the name of a function to call when the interrupt occurs. And the last parameter is the mode of the interrupt. And ChipKit currently only supports falling and rising edge interrupts. So this interrupt will occur when the pin goes from high to low, when it's falling. And these interrupts will occur when the pin goes from low to high, when it's rising. And then, so this configures the interrupts, and then it prints out that the Fubarino attach interrupt message to the serial port. Okay, the ISRs, the interrupt service routines, A, B, C, D, and E, are just functions that I've defined up above. And so I have these 5 functions, and each function does the same thing. What I've done here is I've created a volatile uint32 array that is 5 elements long, 0, 1, 2, 3, and 4. Initialize them to 0, and then when an interrupt occurs, if interrupt service routine A occurs, then it increments that value. So we're counting how many times the interrupt occurs, and we're also going to print out on the serial terminal that interrupt has occurred. Now, it's not the best idea to print from interrupt routines, but for the demonstration of the ISRs, I'm doing it here for illustration. Okay, and then the same thing occurs in all the other interrupts, but I'm incrementing a different array element in each interrupt so that we could count our debounces or our bounces. We're counting our bounces in the circuit. Okay, and then our main loop down here, what it does is there's a delay at the bottom for 1 second. So every second this loop is going to run. And the first thing it does is it inverts the built-in LED. So it toggles that LED every second so that we can see the programs running. And then there's a little for loop here. And what the for loop is going to do is it's going to print out a letter, A, plus our iterator. So our iterator is I, and we're going to go from I to the size of the ISR array divided by the size of a uint32T. The size of function returns the amount of memory allocated. Because this is an array of uint32s, I'm dividing by the size of a uint32 so that I get the number of elements in the array. And then we're going to increment. And then, so we're going to print out A, B, C, D, E here equals, and then the number of interrupts that have occurred since this loop was last run, a comma, and a space. And then I'm going to reset that iterator to 0. So every second it's going to reset the count to 0. And then we're going to print a new line. And so that's our loop. It'll continuously run once the program starts. And we'll be able to see the interrupts in action. So I'm going to open and start the program. And the first thing we could see, and it's weird that I only see C and D, but these are, C and D are rising edge interrupts. Usually we see C, D, and E. Let me close this and I'm going to reset the program and see if we see that. Okay, open it again. I'm only seeing C and D. I wonder if I broke something. I wonder if E is not pulled up correctly. Let me pause my video and check that out. All right. Yeah, that's exactly what happened. The resistor on the pin 24, I was changing some resistors around, and when I plugged it back in, I got it tied to ground, and so the interrupt wasn't triggering on startup. So if I move this back to 3.3 volts, so now the pull-up is now back to 3.3 volts. And then let's restart the program and see what happens. So I am going to close the program, reset it, and reopen the terminal. Yeah, and so I got ISR C, D, and E. So and what you see is the first time the loop ran, it counted 1 interrupt on C, D, and E. And so you see every second it tells you the number of interrupts that have gone by in the previous second. I'm going to resize this here so it doesn't get into the little window down in the bottom of the screen. Okay, so the first thing I'm going to do is I am going to try to very quickly, and you can see what I'm doing with my finger down here in the bottom, I'm going to very quickly try to trigger an interrupt on the resistor with no pull-up, or with no debounce cap, as fast as I can. So I'm just going to bounce the wire off of it. And I did that, and you see I got 252 interrupts called. I'm going to try it again. That was 25 that time, but I suspect it might have gone 62, 104, 26, 300. So you can see very, just doing a quick bounce very quickly generates hundreds of interrupts. Okay, so next I'm going to do the, and this should be well, it's really hard to see here because this is a rising edge, but it's hard to see because there's so much, it's so bouncy. Okay, so let's next try the 0.1 microfarad, and I'm going to do the same thing. This is on E. So there I got six bounces. 7 bounces. Okay, 7 bounces. And this is, let's see, if I just press and hold it, I got no interrupt. But if I let go, I got 5. It's on the rising edge. So on the falling edge, well, that time I got 8. Here I'm just rubbing the wire up and down on the resistor lead, and that rubbing up and down on the resistor lead will trigger interrupts just because you're hitting parts of the wire where there's probably some oxidation, and so you still get bounce even though you're touching. All right, so next I'm going to do the 1 microfarad cap and try to bounce it. And this is interrupt D. So I got 9 there, 4 there, 1 there, 1 there. I'm going to do the other 1 microfarad. This is on this is a 10K resistor. This one is not triggering at all. Did I do the same thing and plug the wonder if I got the pin plugged into the wrong. I might have got the resistor plugged into the wrong pin. Let me. Oh no, it triggered B. There it is. All right. I think I have some leads touching, and so my caps may not be working. Here is interrupt 0 or the A interrupt. 16. This is a 0.1 microfarad cap. 4, 12, 7. But then, you know, the real star here that shows off the bouncing is the C interrupt. Right there, I got 204 bounces, right? Okay, so that is a good demonstration of the bouncing. All right, so thanks for watching, and this has been a demonstration of the Fubraino Mini 2.0 interrupts. And I will post the code in the video for those watching on the internet.